So, no, you cannot turn the radioactive parts of a Brazil nut or a banana into a fission reactor. It takes more than just radioactive materials to create a fission reaction. So a Brazil nut has three main radioactive materials in it. It has potassium-40, way too small to be able to turn into a fission reactor. And then it has your radium-226 and radium-228. Those are definitely much larger isotopes, but they're not large enough. The size of an isotope, which is basically just a flavor of an element, determines whether or not it's going to be able to fission. So if you have a very large element that's having trouble trying to stay together into one mass, it can fission. So here you have your chart of the nuclides. As you go higher and higher on this chart, you have more protons. If you go this direction on the chart, you have more neutrons. Zoom in here, you can see hydrogen. It has only one proton, then two protons, three protons, and these are your flavors, your isotopes of your different elements. So as you zoom up here, like I said, you're going to get higher and higher on it, more protons, more neutrons, and you can zoom into these heavier elements here. And here you have your radium-226 and your radium-228. In order to fission in a reactor, you actually need to be up here in your uranium level and higher. And like I said, when you have that many neutrons and protons in an element, those nuclear forces have a lot of trouble trying to keep all of those neutrons and protons together to where it wants to split up. So here's an animation I found of a neutron coming into this nucleus. And what it does is it makes it just slightly too large, just over the edge. And that causes it to behave like a liquid drop, and it just doesn't want to hold together. Those electrical forces of those protons causes it to want to repel against each other until it splits into these two elements called fission products and neutrons. In a fission reactor that's operating at normal self-sustained reactions is at criticality. That means that one of those neutrons will go on to another uranium element, cause it to fission, which produce more neutrons. One of those will go on to another one, and you have criticality.